Dear students, in this lecture we are going to discuss another problem which can be solved using the greedy programming approach, and that problem is called the knapsack problem. So first of all, let us see what is the knapsack problem. So imagine that a thief is robbing a store and he can carry a maximum weight W into his knapsack. He has a knapsack into which the maximum weight he can put is W. And in the store there are n number of items which are available. And let us say these items are indexed by a variable I. Okay, so this is the first item, second item, third item, fourth item, fifth item, and so on. Okay, and suppose this is I currently. So weight of ith item, every item has a weight, is Wi, and it also gives a profit, and the profit is Pi. So we have P1, W1, that is the W1 is weight of item 1 and P1 is the profit of item 1. Similarly, weight of item 2, profit of item 2, and weight of item I, profit of item I. Okay. So the thief wants that the items should be picked in such a way that he carry only those items for which he gets the maximum profit. Okay, so he wants to select the items because he has a limit. He can put only up to capital W weight in his knapsack. So he has to pick only those items which carry maximum profit, which give him maximum profit, and he can put maximum number of items into the knapsack. Okay, so these problems, the knapsack problem which we are discussing, they are actually two kinds. So first kind is 0-1 knapsack. 0-1 knapsack means there are n items in the store and you can have only one of each. It means you must leave an item or take an item. That is 0-1. Okay, so pick item 1, leave item 2, pick item 3, pick item 4, leave item 5. That is called 0-1 knapsack. Okay, and here in such kind of problems the greedy approach does not work, the dynamic programming approach works. Okay, but the second kind of problems, which are called fractional knapsack problems, in those problems we can take a fraction of each item. Okay, so instead of just picking or leaving an item, we can pick a percentage of an item. We can leave an item, we can pick an item, or we can pick a fraction of it. Okay, for example 20%, 40%, 60%, 80%. Okay, so that is called the fractional knapsack problem. And in fractional knapsack problem, both the greedy and the dynamic programming approaches, they work. So now the fractional knapsack, because we are talking about the greedy problems, greedy approaches, so we will solve this fractional knapsack problem. So we already know that in fractional knapsack the thief can take a fraction of ith item and let this fraction be denoted by xi. Okay, so the fraction lies between 0 and 1, and if the thief decides to pick an item I, then how much weight that item will contribute to the total weight? The fraction of the item picked, that is xi, multiplied by the weight of that item. Okay, so if the weight of the item is 10 and we are picking only 20% of it, okay, so it will be 0.2 so it will be 2 only. Okay, so similarly an item also has a profit. Okay, so if you are picking an item I, then the profit it contributes to the total profit is xi into pi. Okay, so now what is our goal? We have to maximize the profit. Okay, so the profit of an item I is xi into pi. So the profit of all the items will be summation I from 1 to n xi into pi. That is the profit of all items, and we have to maximize it. We have to earn the maximum profit, but there are some constraints. What are those constraints? Your weight, this is the total weight, right? So for each item I, we have the weight equal to xi into wi. So we find a summation of all the weights, and it should be less than equal to the total capacity of the knapsack, that is capital W. And the fraction which we can pick for an item, it lies between 0 and 1, and the items which we are picking, total n items are there, so we can pick the items starting from 1 to n. Okay, so these are the constraints, and we assume that the profits and weights are positive numbers, and the optimal solution can be obtained by setting xi into wi when your weight, the total which you are picking, the weight is equal to the capacity of the knapsack. In that case you will be getting the optimal solution. Okay, so the weight which you are carrying into your knapsack should be equal to the capacity of that knapsack. So how to solve this? Let us try a number of greedy approaches and see what are the results. So the first option is consider the objects in non-increasing profit values. So what this option is saying, let us take an example. Suppose this is item number 1 to 3. So there are 3 items, n is 3, and weight of ith item is, weight of item 1 is 2, item 2 is 3, and item 3 is 2. And then profit, so it is 100, 120 and 10. Okay, and what is the capacity of the knapsack? Capacity of the knapsack is 4. Okay, so we can reach the optimal solution when the items which we are picking, their total weight is equal to 4. Okay, and it is saying that consider the objects in non-increasing profit values. Okay, so we are considering the profit values, and these are non-increasing. Okay, it means we are considering them into in decreasing order. Okay, so first, the maximum profit which we can earn is by picking item 2. So we pick 100% of item 2. Why? Because the weight of item 2 is 3. Okay, so weight is 3, and now if we pick 100% of it, still we have a space for weight 1 inside our knapsack. Okay, so the weight which is left, which we can put inside the knapsack, is 1 if we pick 100% of item 2. And the profit it gives, because we are picking 100%, it will give us 100% profit, right? So 120 will be the profit which we will earn. And now we are left with weight 1. Okay, so is there any item which we can now put inside the knapsack 100%? No, this item number 1 has weight 2. Similarly, this item number 3 has weight 2. Okay, so we have to choose a fraction of these items. We can pick either item 1 or item 2 according to a fraction. Okay, but what is the order in which we are picking the items? We are picking them in non-increasing profit values. So out of item 1 and item 3, the maximum profit we are getting is by picking item 1. So we will pick item 1. Okay, so now can we choose 100% of it? No, we cannot, because we are left with only 1. The weight which we are left with is only 1. So we have to pick only 50% of it, so that W is equal to 1 minus 1. Now we are left with 0. So profit in this case is also 50%. So out of 100 we will get only 50. Okay, and what is the total profit which we are getting? It is 170. Okay, so this is the solution which we are getting by choosing the option 1. Okay, so now let us go to option 2. What is option 2? Consider the weights in non-decreasing order. Now we are going according to the weights. So weights we are picking in non-decreasing order, right? So we will pick the minimum weight first. Okay, so which is the minimum weight? Item 1 has weight 2 and item 3 also has weight 2. Okay, so there is a tie here. Let us say we pick item 1. This is using option 1, the solution which we got using option 1, and let me write the solution using option 2 here. So we are picking item 1 and we can pick 100% of it because its weight is 2, and we can still put another 2 kgs say into the knapsack. Okay, so profit which we are getting with item 1 is 100, right? Okay, so now we are left with weight equal to 2, and now we will pick according to non-decreasing order of weights. We will obviously pick item number 3 next, and here also we can pick 100% because its weight is 2 only. So 2 minus 2, now we are left with 0, and the profit which we are getting by picking item 3 is 10. Okay, so these are the 2 items which are picked, and the total profit is 110. So we can see, now we can compare option 1 and option 2, and we can see that option 1 was giving us more profit as compared to option 2. Is there any other solution? Can we get even more profit? So let us see. There is another option, that is option 3. What option 3 is saying? It is saying that maximum profit per unit of capacity means PI by WI, means what each unit of an item, what amount of profit each unit of an item is giving. Okay, that is PI by WI. We have to pick the items in that order, and in a non-increasing order means first pick up the maximum item, first pick up the item with the maximum value of PI by WI. Okay, so in order to do this, first we have to find PI by WI. Okay, so for item 1 it is 100 by 2, that is 50. It means 1 unit of item 1 is giving us a profit of 50. And similarly for item 2 it is 120 by 3, so it is 40. 1 unit of item 2 is giving us a profit 40, and this is I think not visible, so it is 3, 2 and it was 10. So one item is giving us profit equal to 5. So now we have to pick items in non-increasing order of PI by WI. So first, the maximum profit which we are getting is by picking item 1. So we will pick item 1 and 100% of it will be picked, and the weight which we are left with is 4 minus 2, that is 2, and the profit which we are getting is 100, right? So this is done, and now we move this is done, and we move to the next item which we can pick, and the item which we can pick is item number 2, right? It is giving us 40, profit equal to 40 for each unit of item 2. Okay, but now can we pick 100% of it? No, it seems that we cannot pick. So item 2 we cannot pick 100%. Why? Because our capacity of knapsack is only 2 and the weight of this item is 3, so we have to pick a fraction of it. Okay, so it will be, the weight is 3 and we can pick only 2 units of this item. Okay, so it will be 2 by 3. Fraction which we can pick is only 2 by 3. Okay, so when we pick 2 by 3, then weight which we are left with, we are picking, total weight is 3 and the fraction which we are picking is 2 by 3. So we are picking a weight equal to 2, and what we are left with, 2 minus 2 equal to 0. Okay, and the profit which we are earning is, again the total profit is 120 and we will get 2 by 3 profit, so it will be 80. Okay, so now we can add up the total profit and it is equal to 180. So we can see now that the option 3 is giving us the optimal solution, and this is the approach which we follow in solving this fractional knapsack problem using the greedy approach, right? So now let us see the basic algorithm. Although we have done a thorough example, but still let us see what is the algorithm. So the algorithm is rank the items by value by weight ratio, that is PI by WI. So you have to sort the items such that the item with the maximum value by weight ratio is at the top and the item with the minimum value by weight ratio is at the bottom. So it means that if there is an item I and then another item J, and PI by WI of item I is greater than or equal to PJ by WJ of item J for all I less than J. So means all I's which are at the top or which are at the beginning of your list, for those items the PI by WI ratio is higher than other items which are lower, which are later in your list. Okay, so it means you are considering the items in the order of non-increasing ratio or decreasing ratio, and we take as much of each item as possible. Okay, so the items except the last item, so you are picking a number of items, so I, J, K, L, suppose. So the items, all the items except the last item, they will be picked 100%, and for the last item you will pick a fraction of it, right? So here we have another example. Here the capacity of the knapsack is 60 and these are the details of the items. We have 4 items, A, B, C and D. We have the weight of each item, the profit of each item, and then we are calculating PI by WI ratio of each item. Okay, so we will arrange them, we will sort them in non-decreasing order. So the first item will be B, then we will have A after B, and then we have C, and then we have D. So the items will be sorted in this order. Okay, so first we will pick item B. Item B will be picked 100%, right? And then after picking 100%, the weight which will be left in the knapsack will be total weight is 60, and the item of and the weight of item B is 10. So its weight is 10. Okay, and we will be left with 50. And then next we can pick and the profit here which we will get because we are picking 100%, so 100 it is the profit of item B, so we will get a profit of 100. Then next we will pick item A, and for item A also we will pick 100%. Okay, so after picking 100% of item A, the weight which is left in the knapsack is 50 minus weight of item A, that is 40. So we are left with weight 10, and the profit which we are picking is which we are getting is 280. Okay, then we move on to item C. So item C, we are left with a weight 10, and the weight of item C is 20. So we have to pick half of it, 50%. So if we pick 50%, weight which we are left with is 0, and profit is 50%. Okay, so the profit which we are getting is 60. Okay, so this is how we are calculating the profit. 1 into 100, that is, it means we are picking 100% of item 1, and 1 into 280, and then half into 120, right? And for item D we are not picking it, so 0 into 120, so 440 is the total profit. Okay, now this is the detailed pseudocode, and here we have n items, we have weights, profits of all the items, and we have the capacity of the knapsack. The first step is sort the items according to PI by WI ratio. Okay, and this is sorting, and we have to sort n items, so its complexity will be order of n log n. Okay, and then we have an array xi. Xi indicates the fraction of each item which we are picking. So how much fraction of each item we are picking here? Initially, it is initial for all the items. There are n items. For all the items, it is initialized to 0. Okay, suppose we have 4 items. So for all the items, this will be initialized to 0. It means we are not picking any item. We have not picked any item yet. And weight is another variable which is initialized to 0. Means initially the weight of the knapsack is 0. This is the capacity, capital W is the capacity, and weight stands for the weight which we have put inside the knapsack. So till now we have not put any item inside the knapsack, therefore weight is 0. Then there is a simple for loop. It is running for all the items, so we will analyze all the items one by one. Okay, so items are already arranged in the sorted order. Okay, so first we will pick the ith item, that is the item initially I is 1, so item at the first location will be picked. And after picking that, let me incorporate the okay. So let me use another simple example, because there are 4 items in that example. I want to consider only 3 items. Okay, so initially this is the scenario. So let us take the same example which we took earlier. 2 3 2. These are the weights, and profits are 100, 120 and 10, and the items are 1 2 3, and PI by WI ratio is 50, 40 and 5. Okay, so it is first we have to sort them according to the value of PI by W. So this is by chance already sorted. Okay, then for all the items we initialized xi equal to 0 and weight is 0. Then for I equal to 1 to n. So initially I is 1. If weight is 0 plus WI, so weight of item I, WI, it is 2. So it means if we pick 100% of item I, then we will put all the weight of that item inside the knapsack, and it is possible only if it is less than or equal to the capacity of the knapsack. So here the capacity of the knapsack is 4. Capital W is 4. So this is true. It means the weight of item I is less than the capacity of the knapsack. It means we can put this item inside the knapsack. So what we will do? We will make xi equal to 1. It means we are picking 100% of item I. And now the weight of the knapsack will increase. Weight is equal to weight plus, that is 0 plus weight of item I. So now the weight becomes 2. Okay, so else we will not execute for item I equal to 1. So it means we move further inside the for loop. Okay, I think the for loop should end here, right? This is not the part of the for loop. Okay, so now we move to the next item. Now I is equal to 2. Okay, so again, if weight, now weight is 2 plus WI. WI is item 2's weight is 3, is less than equal to capacity of the knapsack. Is it true? No, it is not true. So it means we will not pick 100% of it. Okay, so these things will not be executed, else part will be executed. So what will we do? If we cannot put 100% of item into the knapsack, we have to decide a fraction of it. Okay, so else part is doing that. So in the else part we are deciding the fraction. So fraction, that is xi is 2 here, will be equal to capital W, that is 4 minus the weight of that item. The weight of that item is 3. It is the weight which we have already put. Okay, so this is the capacity and we have already put a weight equal to 2. Okay, so what is the remaining capacity? It is 2. So, and what is the weight of item I? Item I's weight is 3. Okay, so it means we can put a fraction equal to 2 by 3. We cannot put 100%, we have to put 2 by 3. Okay, and we have decided the fraction. Now weight, which now because by picking this much fraction, by picking 2 by 3 of this item, the capacity of the knapsack will become full. Okay, so now we can simply say the weight of the knapsack now becomes equal to the capacity of the knapsack. And now we do not need to explore any further item because our knapsack is already full. So we execute a break here. Okay, and xi is 2/3. So this is how this for loop ends, and after the for loop we calculate the profit. So for profit there is a simple for loop again. Initially profit is 0, and then for all the items we are simply multiplying the fraction of each item multiplied by the profit of that item. Okay, so initially I is 1, so 1 xi is 1, so 1 into pi, that is 1 into p1 100, right, plus x, then I becomes 2, x2 is 2/3 and p2 is 120. Okay, and then I becomes 3, so x3 is 0, we are not picking the last item, multiplied by p3, that is 10. Okay, so this is the total profit which we will get. It is 100 and it is 80 I think, and it is 0, so total profit which we are getting is 180. Okay, so now let us analyze this loop, this algorithm. So this is the sorting which we are doing at the beginning. It will take order of n log n time, and this is a for loop running from 1 to n, so linear time will be taken by it. Again there is a for loop, so this for loop is also running from 1 to n, so linear time will be taken by this also. So again here we have a for loop, its time will also be linear, so the total time will be order of n log n, plus there are 3 for loops, order of n plus order of n plus order of n. So we can ignore the values in asymptotic complexity, we can ignore the time complexities which are which are lower, and we can keep only the highest time complexity, so it will take order of n log n time. Okay, so this is the time complexity analysis, and this algorithm is not taking any extra space, so space complexity is constant. And what are the limitations of this knapsack greedy approach to knapsack problem? As I already told you, this does not work for 0-1 knapsack problem. Okay, so let us take an example to appreciate this. So here the capacity of the knapsack is 30, and these are the items and their weights, their profits, their pi by wi ratio, and they are already sorted according to pi by wi ratio. And this for this problem we have to solve it by 0-1 knapsack problem, means we cannot pick a fraction, we have to pick either a whole or we have to leave it, we have to drop the item. Okay, so the maximum profit which we are getting is by picking item A. So we will pick item A, weight is 5, so capacity after picking A which is left in the knapsack is 25, and profit which we will get is 50%, 50. Okay, then next, still because there is a space for weight equal to 25, so we will pick item number B. Okay, after picking B, now what is left? 25 minus 20, 5. The weight inside the knapsack which is left is equal to 5, and the profit which we are getting is 140. Okay, so next, can we pick item C? No, we cannot pick item C because the weight of item C is 10 and the capacity remaining inside the knapsack is 5. We cannot use fractional knapsack. As I said, this has to be solved using this greedy approach 0-1 knapsack problem. We have to pick an item or leave an item. Okay, so it means the total profit which we can earn using the greedy approach to solve the 0-1 knapsack problem is 190. But is there any alternate solution to this? Is greedy approach giving us the optimal solution? Let us analyze. So if instead of picking the items A and B, I picked the items B and C, then what would happen? The weight of item B is 20 and the weight of item C is 10. So the total weight is 30, which is equal to the capacity of the knapsack. And the profit of item B is 140, profit of item C is 60. So the total profit which I would get by picking B and C is 200, right? Which is better than this. So it means greedy approach does not work for solving the 0-1 knapsack problem, right? So this is the greedy approach to solving the fractional knapsack problem. Thank you.